Today I'm going to talk about PCBs in American waterways. This presentation covers how PCB enter water bodies, their distribution, health impacts, current policy actions, and remaining challenges. Here is the table of content which lists every figures and charts I use in the presentation. PCBs are synthetic chemicals once widely used in industry. Although banned in 1979, they persist in the environment due to their stability and resistance to breakdown. PCBs leak into the environment during manufacturing and disposal, then settle into sediments. This chart illustrates two processes. On the left is the bioaccumulation. PCBs build up in fat tissues of animals, starting with invertebrates and moving up the food chain. On the right is the biomagnification. PCB levels increase as predators eat contaminated prey, ultimately affecting humans too. Although banned decades ago, PCBs are still widespread. This map shows the sampling size from the 2018 and 2019 National Rivers and Streams Assessment. A total of 1,851 river and stream sites were included. On the left, you can see the result from the subsample of these locations. PCBs were detected in 100% of the 290 fish fillet samples, meaning PCB contamination is truly widespread and not limited to one region. Here is the Great Lakes region, one of the most heavily PCB contaminated areas in the United States. This chart from the EPA shows the mean total PCB concentrations in the lake trout and walleye at different sampling locations between 1991 to 2009. Each bar represents the average concentration over time at a specific site. As you can see, the overall PCB levels have been declining over the years, but according to the original EPA report, there are still three major concerns. The concentration remains above the target level, the rate of the decline varies across lakes, and the decline is slowing down or even stopping in some places. So overall, even with the progress, PCBs remain a long-term concern here. Now let's look at the human health impact of PCBs. PCBs affect human health in many ways: cancer risk, reproductive harm, neurotoxicity, immune suppression, and so on. The chart here shows the blood serum PCB levels among U.S. women aged 16 to 49 based on national survey data. The 95th percentile exceeds 245 nanograms per gram, which is a level considered concerning for reproductive and developmental health, especially in women of childbearing age. Given these risks, the U.S. has taken multiple actions. First, the U.S. banned the production and use of PCB as early as 1979. Second, for equipment that still contains PCBs, there are rules requiring proper registration, labeling, and regular inspection. Third, multiple agencies have set strict exposure limits for PCBs in different parts of our environment. Here you can see the safety threshold set for water, food, and air. For example, the EPA limits PCB levels in drinking water to just 0.005 ppm, and the FDA allows no more than 2 ppm in fish. Fourth, there are regulations about how to safely dispose of PCB waste and contaminated materials. And lastly, although the U.S. hasn't formally ratified the Stockholm Convention, it has still voluntarily followed many of its elimination targets. Besides regulation, the U.S. has also cleaned up existing pollution. A key example is the Hudson River cleanup. From 2009 to 2015, over 2.75 million cubic yards of contaminated sediments were removed. This chart shows water PCB levels before and after dredging at 5 locations. As you can see, the concentration dropped significantly. For example, in Thompson Island, PCB level dropped from 45.3 parts per trillion before dredging to just 9.1 ppt by 2022. Similar declines are seen at all 5 sites, some by up to 79%. Another example is the Lake Michigan, which improved without dredging mainly through emission reduction. This line graph shows the temporal trends of PCB concentration in both fish and air from 1970 to 2015. Both curves show a clear exponential decline, highlighting a steady reduction over the decades. Although we've seen progress through policy action and cleanup projects like the Hudson River, PCB remain a persistent environmental threat. As we have mentioned before, in recent national fish sampling, 100% of the fillets has PCBs. Even more concerning, 45% of sample river miles had fish with PCB levels above the 12 ppb cancer screening level for general fish consumers. And if we look at the high-frequency fish consumers, the threshold is even lower, 2.8 ppb, and 74% of the river miles exceeded it. What's worse is that compared to the data from 2013-2014, there's been no statistically significant improvement in the PCB levels. This indicates that natural degradation and existing effort might not be enough. Long-term contamination requires more aggressive and sustained action, possibly more site-specific cleanups like the Hudson, and continuous monitoring and equity-focused intervention. In summary, PCBs remain a persistent environmental hazard. Although progress has been made, widespread detection and ongoing risks call for continued monitoring and action. Here are all the references. Thank you for watching.